All right, in this section we'll be looking at solving quadratic applications and looking at a few different kind of applications, basically some simple ones. In terms of solving any kind of word problem, we'll always use this similar kind of strategy where you familiarize yourself with the question by drawing pictures or rereading the things, assigning variables to different parts, and then come up with an equation, whether it's an area equation or whatever, and then solving that equation, checking to see if your answer is right, and then writing some kind of a statement to answer the question. So I'll just go through 2 or 3 different ones, but they all will be similar. So the product of 2 consecutive numbers is 240. Product means multiply. Consecutive means one right after the other. So it could be like 10 and 11. But the problem is that 10 times 11 is only 110, not 240. So, but this is the idea. Now, if I don't know what those numbers are, I guess I could keep guessing, but I can also assign them a variable. So let's assign the first one an x. If the first one's an x and the next one's one more than that, then the next, or the consecutive number after the first one, will be x plus 1. So they say the product of 2 consecutive numbers. So the product of these two. So x times x plus 1. The product is 240. Now I've got an equation. So if I look back here, I've sort of familiarized myself with the question, and I've written an equation. Next step, solve. Okay, so to solve this equation, we learned in the last section that we need to get everything over the left side. And we didn't have these brackets in the other one. So let's multiply these together. X times x would be x squared. X times 1 would be 1x. And then is equal to 240. Then we'll bring the 240 over, so I'll have x squared plus x minus 240 is equal to 0. So it's a quadratic, so I made it equal to 0 so that I could use a 0 property. Now I'm looking for 2 numbers that multiply to 240, or negative 240, and have a difference of 1. So 24 times 10, that's 240, but they one has to be a negative. They don't have a difference of 1. How about 20? 20 times 12, say negative 20 times 12, that's 240, but that's they have a difference of 8, not a difference of 1. I wonder if 15 will go into that. 15 times 16. Oh, they're right together. 15 times 16 on my calculator, 225 plus another. Yeah, that's right. That'll be 240. So one of these has to be plus and one has to be minus. Since this is positive, I'll make the biggest one positive and this one negative. So this will be x take away 15 and x plus 16. So I've factored this. Now I can use a 0 property, which says if you have 2 things that multiply to get 0, either this one is 0 or x plus 16 is equal to 0. If I use the addition property now, I get x is 15 or x is equal to negative 16. Okay, so now I know that x is 15, so the next number is 16. So 2 consecutive, what does it say? 2 consecutive numbers is 240. So the first number is 15 and the second number is 16. Their product is 240. I wonder if this would work. Like if I had negative 16, the next number up from that would be negative 15. Would their product also be 240? It would be. It would be positive. So I would go either with this answer or that answer for that question. Let's look at another one. A rectangular field is twice as long as it is wide. Okay, so if I have the width here, If this is the length, but I know the length is twice as much as that. So let's just write, instead of writing L here, I'll write it's whatever this width is times 2, or 2W. The area of the field's 288, so area is 288. What are the dimensions of the field? Well, I know that the area of any rectangular is equal to length times width. So there's my equation. I can plug 288 in for the area. The length I know is 2 times the width. And the width, I guess I'm just using a W for that one. So now, if I simplified, 2W times W will be 2W squared is equal to 288. Again, I've got a squared here, so I'm going to bring everything over to one side. I'm just going to bring it to the right side just so I can keep my 2W squared positive. Okay, I have it equal to 0. Now I need to factor. Always first look for a common factor. There's a 2 that can come out. So 2, and it'll be W squared minus 144 equals 0. Now can I factor that? It's 2 terms, so maybe it's a difference of squares. So maybe it's, can I take the square root of 144? I think so. So W square root of 144 would be 12, and 12. 1's plus, 1's minus. Again, it's a 0 property, so either this equals 0, or this equals 0. We know that 2 is not equal to 0, so I won't use that. But I'll go W plus 12 is 0, or W minus 12 is equal to 0. In this case here, I'll subtract 12 from both sides. I'll get a negative 12, which doesn't make sense in terms of an area, so I'm throwing that one out. On this one, I'll add 12 to both sides, and I get a width of 12. And that makes sense. So this is 12, and they say that the length is twice the width. So this one would have to be 24. So then I'd put a statement in the bottom. The width is 12. The length is 24. Okay, I think they were meters. So that's how you could solve that one. Again, a quadratic, where if there's a quadratic, make it equal to 0, factor, solve. Try a couple more. To determine games are needed a tournament, you can use a formula. Oh, they gave me a formula already. N stands for how many total games there are. X stands for the number of teams. Okay. If a tournament needs 72 games to complete, how many teams came? Oh. So the 72 is how many games there are. That has to get plugged in right into there. So I'm going to have 72 is equal to x squared minus x. Another beautiful quadratic equation. And like we always do, make it equal to 0. So I'll subtract 72 on both sides. Hopefully you're getting good at moving things around rather than having to write minus 72 here and a minus 72 there. If you need to write those in and it works for you, keep doing it. But if you can skip a step, that's good. Now I've got a quadratic. There's 3 terms, so I'm going to try and do the 2 bracket thing. Things that multiply to 72 have a difference of negative 1. So 72, 36 times 2, or negative 36 times 2. The difference is too big there. How about 9? 9 times 8. Hey, they have a difference of 1. So the biggest one I'm going to make negative, and this one positive. This times this is negative 72. This plus this is a negative 1, and that's what I'm looking for. So I'll have my x, and that'll be a minus 9 and a plus 8. Now in solving that, this is all equal to 0. 0 property, this times this equals 0. So x minus 9 is 0, or x plus 8 is equal to 0. On this side, x will be 9. On this side, x will be negative 8. A negative number of teams coming doesn't make sense, so the answer must be 9. Notice that there's two possible answers for the quadratic, but you have to look to see which ones make sense. So 9, here how many teams came? So 9 teams came to the tournament. Okay, hopefully you're getting on to those. One last concept to look at with quadratics, and it's, I don't know if I would call it a quadratic equation or not, but it certainly has variables that have squares in them, which you might be able to solve using quadratic information or tools. The relationship is that exists between sides of a right triangle. Right triangle meaning these two here are at 90 degrees or perpendicular to each other, as we've seen before. And the relationship says if I square this side and square this side and add those together, that will be equal to whatever this side's square is. For example, if this side was 3 and this side was 4, okay, if I square this side, that would be 9 altogether. Square this side, that'd be 16 altogether. Okay, 9 plus 16 is 25. So this side would have to be 5, because 5 squared gives me 25. Okay, so this here is known as the Pythagorean theorem or formula, and I can use it if I know 2 of the sides. I can figure out the third one. Here's an example of how you can do it. You see a cat in a tree. So here's a cat in a tree. There, okay, that's a tree. And you are 10 meters. Here I am right over here. I'm 10 meters from the base of the tree. And I estimate the height of the cat in the tree to be 15 meters. So this is 15 meters. Looks like I have my lines a little bit out of sync, but you get the idea. This is 15, that's 10. What would be the shooting distance to the cat from my position? Again, I'm shooting with a camera, not a gun or a bow and arrow or a slingshot. Not that I've ever done those. No, I actually haven't, but maybe I've thought about it. Okay, so I want to know this distance here. When I look at the right triangle, here's the right triangle. This side over here, the longest side, is always C. We also call it the hypotenuse, but we'll talk more about that in trig. But that's side C, and then these two sides here could be A and B, it doesn't matter. We'll call this one A and this one B. So the relationship for Pythagoras says that A squared plus B squared is equal to C squared. So A squared, so A 15 squared plus B 10 squared is equal to C squared. 15 squared is 225, 10 squared is 100, equals C squared. And now this 225 plus 100 would be 325 is equal to C squared. And in this case here, I could move the 325 over to this side, but I don't think that I can take the square root of that. So we use another principle that they show in your book, and it's called the square root principle. So if I have a letter squared, a variable squared over here, is equal to a number, what I want here is just a C. So eventually I just want a C there. So to get a C, what I can do with the C squared is I can take the square root of it. And the square root of C squared will just give me a C. And that's what I'm wanting. But if I take the square root of this side, I also have to take the square root of this side. We'll learn later that your answer here has to be a plus or minus, which goes along with always having two answers in a quadratic equation. And now I just have to figure out what the square root of 325 is. Where's my calculator? Oh no. Calculator. Here it is right here, coming up. 325. Come on, calculator. Continue with my trial version. Okay, here's my calculator. So clear out of that stuff. So square root's right there. So second square root of 325 equals 18.03, let's call it just 18. So C then is equal to approximately 18 meters. So that's the firing distance between me and the cat. Okay, so in this section we've just looked at a few different examples of places where you can have quadratic functions. There's lots more, like anytime you have a parabola, so you're hitting a ball or any kind of shape like that, that's a quadratic function, and solving that can help you determine different parts of that quadratic equation. All right, hopefully that helps. Try some questions.